Next, we're going to take a look at factoring a sum or difference of cubes, which you are probably not as familiar with as hopefully you are with the GCF and difference of squares. You were just introduced to this last year in Algebra 2, so I'm not sure how much practice you got depending on which course you were in. I did give you the formula for factoring sum or difference of cubes on your vocab sheet. I hope that you are referring to that throughout this lesson so that you can keep all of your vocab terms straight. So factoring sum or difference of cubes starts off the same way factoring a difference of squares does, except for we're taking the cube root. Cube root of x cubed is x, cube root of 8 is 2. The second part is a bit more complicated, so I'll try to talk slowly. I know I have a tendency to rush. And I will also show you once we're done factoring that it does indeed work. Alright, so now we're going to focus on that binomial we just created, x minus 2. Take the first term and square it, opposite sign, multiply the two terms together, x times 2, always plus second term squared. Alright, so this part you do not need to write down. This is just showing you that this complicated mess that we just made out of this simple binomial, x cubed minus 8, does actually equal what we started with. So I'm going to distribute the x to every term in the second set of parentheses, x times x squared, x times 2x, x times 4. Now I'm going to distribute the negative 2. Negative 2 times x squared, negative 2 times 2x, and negative 2 times 4. And as you can hopefully clearly see, the 2x squared cancels with the negative 2x squared, the 4x's cancel, leaving us with x cubed minus 8. There are a ton of applications of factoring, so it's important that you understand all of them, even though it doesn't really look nice. All right, so let's go through that one more time. Now this 3 that's out front of my sum of cubes, y cubed plus 64, is already factored out. So I'm going to leave it. And I'm not really going to do anything with it except to write it down again. Same process, cube root of y cubed plus cube root of 64. Again, first term squared, opposite sign, multiply the two terms together, always plus, second term squared. So I'm not going to go through this one to show you that it works, but again, we saw that on the first one, that process works.